zoom, page width, view, full screen, down the bottom. Okay, so in the next part, he wants you to calculate, or pretty much calculate this antiderivative here. So this is now part 2, the last part of number 3. 1 to 2 minus 2x squared plus 17x minus 7 over x minus 3 times x squared plus 4, like that. Now, in fact, this here we did in the previous part where we got the a, b, and c. So I know already that I can write this as, what's a?
It's 2.
And b?
B it's minus 4.
And c?
5.
Okay. Now we can calculate the antiderivative. So the first one will be log x minus 3 with the 2 in the front. Now this one here, I'll do a little trick for you. I'll change this 4 into 2 times 2. And the reason for doing that is there's a trick here. If the derivative of x squared plus 4 is equal to the derivative, if the derivative of this is equal to the top, then this is equal to log. Do you remember this trick? No, okay. Well, if you want to do it the long way, is you let u equal to x squared plus 4 by substitution. But anyways, the trick is, if you can get the derivative on the top, then you can say it's equal to minus 2 log x squared plus 4. Okay? And then likewise here, this one makes the tan inverse. And again, you have to use a substitution u. And what, do you remember doing this? You have to take the 4 outside and stuff like that.
Yeah.
So if you let u equal to x over 2 here, you can simplify this.
U equal x over 2?
Yeah, because what will happen is you'll take the 4 outside, so this will be x squared over 4, which will be x over 2 squared plus 1. I'll write in red. It'd be x over 2 squared plus 1 when you take the 4 outside.
Okay, so it's going to be plus half then?
5 over 4. And then you can use the tan inverse. And then you put in the two limits, 1 and 2.
I think it writes down this.
Well, I'm using this formula, that 1 over u squared plus 1, the antiderivative of this is tan inverse. We had one class on this. Don't remember it? You check your notes. We had a class. We did sine inverse, cos inverse, and tan inverse.
Yes.
Do you remember?
The question is not going to tell us use tan inverse.
No. No. I'll tell you how you can know which ones to use, okay? When the top is linear and the bottom is quadratic, it's probably the log. When the top is a constant and the bottom is quadratic, then it'd be a tan inverse. And when the top is a constant and the bottom is linear, then that will also be a log. Do you want me to make a little note of that? So, I'll write it here. So constant over linear, linear over quadratic. What else do we have? Constant over quadratic. What other possibilities could we have? Constant, no, not constant over constant. I suppose you could have quadratic over quadratic.
Yeah, and quadratic over linear.
And quadratic over linear. So in both of these cases here, you have to try to simplify it by using partial fractions first. And what you should try to do is simplify it into maybe one of these problems. This one here should be a log type of answer. This one here should also be a log type of answer, and this one here should be a tan inverse type of answer, or maybe something very similar to that. But anyways, just before I go on here, I will skip. Can you listen here? I have to put in the 2 and the 1 and then simplified, but I'm not going to do that now because that's just boring. But you put in the 2, you put in the 1, blah 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 blah, and you're supposed to show at the end you get this 2, and they don't want the decimal, they want this. Now look, you can kind of see how this works. If I put 1 in here, what do I get? 5 over 4 tan inverse a half. Oh sorry, should be a 2 here. And then if I put in 2, what's tan inverse 1?